Namaskar students. So let us learn how to use t-test for one sample today using an example. So in this question we are given, let us consider the average rainfall of a given area is 8 inch. However, a local meteorologist claims that the rainfall was above average from 2016 to 2020. So we are given the average rainfall is 8 inches, but according to the meteorologist, the claim is that this is above this rainfall and argues that the average rainfall during this period was significantly different from overall average rainfall, and data is given as this, right? So we will first find out that what is the standard deviation, okay? And for that we have to find the mean. So rainfall in inches is given as 8, 5, 7, 5, 6. So we have here 5 observations. Well students, in my previous video 179 number, calculating the standard deviation, we have learned how to find the mean and the standard deviation for the same data. So considering that, we can say that the sample mean is here 6.2. The standard deviation small s is 1.3 and n is here 5. And in the problem we are given that the population mean is 8 inches rainfall, which is. So we will first frame the null hypothesis. We can say that the null hypothesis is annual rainfall from 2016 to 2020 is same as the overall annual rainfall of 8 inches, right? So we can have the null hypothesis as it is same as the 8 inches. And the alternative hypothesis we also can frame, that is the average rainfall from 2016 to 2020 is not same as the overall average annual rainfall of 8 inches. So alternative hypothesis is this is not same as 8, right? So for finding the t value, we have to find the t value. This is calculated from using this formula. So t is here absolute value of the mean score of the sample and the population mean divided by the standard error of mean. And this standard error of mean is, we know the formula for that, which is equal to s over under root small n, right? So we have already learned how to find the mean, standard deviation, right? So using that we can find the standard error. So here s is 1.3 and n is 5, so it is under root 5. So our t is here absolute value of 6.2 minus 8 divided by 1.3 into root 5. So if we do the calculation, this comes out to be 3.092, right? So here calculated t is 3.092. Now we have to locate the t value at 0.05 or 0.01 as we assume the level of significance. So let us consider the level of significance is 0.05. So we have to find the t value for degree of freedom, which we can calculate as n minus 1, which is equal to 5 minus 1 equal to 4. So for degree of freedom equal to 4 and 0.05 level of significance, for the null hypothesis we have to use a two-tailed test. So this is degree of freedom 4 and 0.05, it is 2.78. So t at 0.05 is our 2.78. Now you observe that the calculated value, this is the calculated value, this calculated value is greater than the t at 0.05, right? So our null hypothesis is rejected. And if null hypothesis is rejected, it means alternative hypothesis is accepted, right? So alternative hypothesis, we frame that the average rainfall from 2016 to 2020 is not same as the overall average annual rainfall of 8 inches, right? This one. Clear? So this is how we use a t-test for one sample.